Continuing with our long division, on the next page, part B, I'm going to write my 2x minus 1 down first. This one's just written differently, but it's the same thing. And I'm going to write this polynomial, the 8x squared plus 2x minus 7 underneath. Now it is in descending order and there's no missing terms because I have x squared, x to the first, and then just my number. So remember what we do when we ask ourselves. We ask ourselves, what can I multiply times 2x to get 8x squared? Well, let's simplify this a little further. What can I multiply times 2 to get 8? Well, 4. What can I multiply times x to get x squared? X. So I can multiply 4x times 2x and I should get 8x squared. So 4x times 2x gives me 8x squared. 4x times negative 1 gives me negative 4x. Okay? So remember, you distribute. And remember, after you distribute, you should get the same thing on top and bottom. The 8x squared should be the same. And then you subtract. And when you subtract, you change all the signs behind it. That became a negative 8x squared. That became a positive 4x. I'm going to cancel out my leading term. It has to cancel out. If it doesn't cancel out, something's wrong. And I have 2x plus 4x gives me 6x. Bring down my minus 7. And I ask myself again, what can I multiply times this 2x to give me 6x? Well, this 2x already has an x, so I don't need to multiply anything times x. But what can I multiply times 2 to get 6? 3. So that means I can multiply 3 times 2x and I will get 6x. 3 times negative 1 and I get negative 3. Alright, again I have the same thing. I have 6x on top and bottom, so I'm going to start subtracting. And when I subtract, I change all the signs to the opposite. This becomes a negative 6x. This becomes a positive 3 and cancels out the leading term. I have negative 7 plus 3, that gives me a negative 4. And when I rewrite this with my remainder, remember this is my remainder, I'm going to have minus, because it's a negative 4, minus 4 over the thing on the outside, the 2x minus 1. Now our next example is a little harder because it doesn't have it in descending order. So I'm going to have to rewrite this in descending order first. So I'm going to write the thing that's on the bottom on the outside. It stays the same. And then this, notice it's circled saying, hey, I'm not in descending order. So descending order, remember, has the highest exponent first. So descending order would actually be 2y squared first, then negative 3y second, then my minus 15 third. Okay, so I have it in that order where my x squared's first, then my x to the first, then my number. So now I'm going to put it down into my division problem, and I'm going to go ahead and start. Okay, so I have the first thing I asked myself, what can I multiply times 2y to get 2y squared? Well, we already have the 2. We just need a y. So I'm going to multiply 2y times y to get 2y squared. So y times 2y is 2y squared. Y times 5 is 5y. Change all the signs to the opposite because I'm going to subtract to make that a negative 2y squared and a negative 5y. And remember, your leading term will always cancel out when you subtract down. So when I subtract down, the 2y squared minus the 2y squared cancels. I have the same sign, so I'm going to add and keep the sign and get a negative 8y. And I'm going to bring down the minus 15. Okay? I'm going to ask myself the same thing. I'm going to say, what can I multiply times 2y to get negative 8y? Well, it already has a y, so I don't need to multiply times a y. But what can I multiply times 2 to get a negative 8? A negative 4. So I'm going to distribute that negative 4 to the 2y and get negative 8y. Then negative 4 to the 5 and get negative 20. Remember, you have to have the same thing when you distribute, so I have a negative 8y and a negative 8y. I want to change all the signs to the opposite when I subtract. The 8y's cancel out. I have different signs, so when I subtract, I have the sign, the bigger number is going to be a positive 5 for my remainder. And I'm going to say plus 5 over 2y plus 5. That's the number on the outside, or the polynomial on the outside. So this is my answer in simplest form. And we'll pick up on the next video where we left off.